Guys, how many of you have been shopping before? And well, where are my shoppers? I guess who likes to go shopping?
I like to shop when I have money.
I'm shopping tomorrow. I shop
Courtney,
at Hometown's Food.
that's why I never go shopping.
Yeah, but same.
I shop at Hometown's
I like
Food.
when other people pay for me.
Yeah, that's a good deal too.
I like to go to the Buckle.
Never go
I
to
always,
Walmart on a Saturday.
I always accuse my wife. My wife was like, "Well, I got it on a sale rack," and I said, "You know what? We're gonna go broke saving money.
Yeah, it's true.
We're gonna go broke saving money." She's always buying stuff on a sale rack. She's like, "Well, I got extra stuff." I'm like, "Well, see, that's the problem with sale racks. When you get something cheap, you're like, oh, I can buy something else now, right? So you're still spending the same amount of money. Going broke, saving money. We're going broke, saving money. Crazy.
Walmart been making me think that they have lower prices than their competitors since.
You guys have always been, you've definitely been to a store before and you've seen something that's like 25% off, right? Or 50% off, right? Okay, so we're going to start talking about that a little bit today. 7.5 is going to be strictly what we call percent of change. We're going to talk about percent increases and percent decreases. Like for me, I like it when my salary is a percentage of increase or decrease. Percentage of increase, okay? So goal-wise today, guys, we're going to find a percent of change and a quantity. How much it changed, by what percent did it change? So we've got some vocab right here. Take a look at this, get the vocab down, and we'll look at some examples. I think you'll understand this. I want to hand back your quizzes towards the end of the hour. You guys did a very nice job on them. Just know that when you get your quizzes back today, how long will you have to retake them? 1 week, okay? All right, so let's rock and roll here. Vocab, right in here. Okay, percent of change. First of all, percent of change. How about a volunteer read this one for me right here?
I will.
Go ahead, Mason.
How much a quantity increases or decreases with respect to the original amount?
The original amount. Did you watch?
Yes. Oh my gosh.
Did you do an oh my gosh like 3 different times?
Yeah. Sure didn't expect
The ending?
that main guy,
That main guy.
who will remain nameless in case anybody wants to watch it.
Yeah.
I didn't expect him to
I was
get
like,
it.
that can't happen.
I know.
What are you guys
I
talking
thought,
about? What are you talking about?
I bought a movie in for Mrs. Miller to watch.
Oh my
and
gosh.
What movie?
It's The Departed, and it's one of my all-time favorites. It's in my top 5 movies list. So, great movie. Great movie.
What's your
Well-
number 1 movie?
The guy in
Blues
the end,
Brothers.
you know, and I was afraid. I kept telling Nick, Wahlberg's gonna show back up.
Yeah.
He's got to.
Yeah.
But then,
Yeah.
yeah,
Good stuff, wasn't it?
yeah.
Good stuff.
God.
Hey, Parks.
Mrs. Miller's all like, whoa. Like,
I know it was.
she's razzled this morning.
And Nick said, "Well, I didn't know Wahlberg is in this one or something," or Damon. And I said, "Yeah."
Yeah.
I said he rattled off a bunch of Nick and Matt Damon's name.
A lot of big hitters in that movie.
Yes, there were.
Yeah. Yeah. Okay,
Charlie Sheen.
Mason, let's go back with this one more time again.
How much a quantity increases or decreases with respect to the original amount?
Okay, so we're basically talking about what percent did it increase or what percent did it decrease here. Okay, so the first one I've got right here, guys, percent of increase right here.
That's so weird.
Percent of increase says it's a percent of change when the new amount is more. Okay, since the Republicans have taken office, taken over, gas prices have done what? Went from $1.95 to $2.54. That's your Republican Congress. That's your Republican governor. That's a percent of increase. That's bad, right there. Bad, 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 right? Right? So what's percent of decrease going to be?
Politics
I
are
don't get
bad.
Politics scare me.
Yeah, don't.
Politics are bad.
I agree.
That's why I'm
I'd
going
rather
to
just
go
stay
live
home
up
and
in the
watch
mountains.
Netflix.
Me too. Percent of change when the new amount is less. When it's less, it's going to be a percent of what, kiddos?
What's that?
Decrease. Okay. Got some nice formulas for you. You're going to want to know these formulas, all right? You will want to know these formulas. This is pretty important right here. So maybe star this, highlight this section, do what you need to do.
I just have all those like people that are like trying to survive the zombie apocalypse, like protect me, or I just like die.
Or I just die.
at home watching Netflix, I'd be like,
Okay, percent of change right here.
The zombie apocalypse, I'm sure Queen Maddie.
Here is the formula right here, and I'm going to put an alternative formula up here. Okay, up here. Percent of change right here says this. It says it's the percent of change is the ratio of the amount of increase or decrease to the original amount. Basically, the formula you need to know is this: the amount of the increase or the decrease divided by the original amount. Okay, so I'm going to kind of put an alternative formula right under this, and I think that the way that I write this might make better sense. But guys, it might be an example of say like this: if something costs $20 and its new cost is $30, I want to know what percent did $20 increase up to $30 by. Okay. Now, do you agree that when I start talking about $20 and $30, one of the values is a small value and one is a big value? So wouldn't the increase be the big value minus the small value? 30 minus 20, wouldn't that be the amount that we increase? If I went from 20 to 30, what is the increase? If I went from $20 to $30, what's the increase? $10, right? So if it's a $10 increase, couldn't I have gotten that by 30 minus 20? Okay, so an alternative formula I'll put down here, I'm going to write down here percent of change could also be written with this formula. I like this one here. It means it's the same exact thing as the one I've highlighted, but I want you to write down it's the big number or the big value in the problem minus the little one. And we're going to divide that by the original value. Okay, so it's the bigger value minus the small value divided by the original value. Okay. So example 1 says finding a percent of what here, kiddos? Percent of what? Increase. Make sure you've got this formula down. I think that this first example's rolled over to the second page in our notes. We're finding a percent of increase. You guys ready? Okay. Here it is. Looking for a percentage of increase. Okay, now what I want you guys to understand is this: when I talk about the original value, it's like, what did the problem start with? How many value, or what was the value the problem started with? Okay. In this problem right there, it says, example 1, a school had 720 students last year. So what are we starting with automatically? 720. So what's the original value? Okay. This year there are now what? 745. There are 745 students enrolled. It says by about what percent did the number of students change from last year to this year? We went from 720 originally up to what? 745. Okay. When I start doing problems like this, I like to go in here and say, okay, what's the original value? Well, in this example right here, my original value is the original value is 720. I like to point that out. Okay. So my question is, what's the percent of increase here? Okay. And maybe I should back up to this formula on the first page. Maybe I should tell you, you know what? If we're turning this to a percent, we probably need to multiply this by what in the end? 100 times 100. All right. So you might want to put that in there. Okay. Multiply by 100. So let's go back to this problem right here, guys. In example 1, we're talking about the big number. Is it okay if I put b minus s, as long as you guys don't take that out of context? Are we okay with that? All right.
Yeah, you're pretty full about that.
If I put it over O like that, you know what that stands for, original? You guys okay with that?
SOB.
Okay. In this problem, what is the big value, kiddos? 745. We're going to subtract what value from that? 720. Okay. Now we're going to put that over the original value of 720. We're saying, okay, the student population went up by a certain number of people. What percent of the original population was that? Okay, so 720 is my original, and then in the end we're going to times by what here? Okay. So let me pull my calculator. Guys, the one thing I'll point out about this, when you're punching stuff in here, very important step that you're going to want to make sure that you listen to. When I do the 745 minus the 720 part, you have to hit the equal button before you do what? Before you divide. So hit equals on that top step. You always hit enter, hit equals, whatever, before you do your division, because your calculators nowadays are smart enough to consider order of operations. It'll divide before it subtracts. All right, now I'm going to divide by what, kiddos? Divide that by 720. And do you guys all agree that right here 25 was the difference between these two numbers?
Yes.
Okay. So divided by 720, and that gets you that number, but now you have to multiply by
100.
times by 100. And I think if we go to the nearest tenth of a percent here, kiddos, we'll be in good shape. So 3.47 would probably round up to about what?
3.5.
About 3.5%. So this here, what's the percent of increase?
3.5.
Guys, watch what I do here. I'm going to put a symbol at the end of this. What's that mean?
Increase.
Means population went up by 3.5%. Okay, went up by 3.5%. Okay, what do you guys think about that? You okay with that? Okay with that? Questions about that? Okay, next one then. What are we trying to find, guys? So find the percent of what? Decrease. Okay. So we're starting here. We're starting here and we end higher or lower than that?
Lower.
Lower. Okay? Lower. I like it when gas prices were here and went here. But now, the Republicans have that. This. Republicans have
She's not doing that real fast.
I want to go back when gas was cool. Mrs. Miller probably
Oh,
remembers
heavens.
the lowest I ever remember gas prices was 87 cents a gallon.
Oh, my dad owned a gas station, and
Okay.
I can remember 35 cents,
Oh my
probably
gosh.
25 cents even. you
Really?
know. Oh, yeah.
Holy cow. We should have
Yeah.
been hoarding that stuff.
I know.
Oh my gosh.
Yeah.
What were you
You're like,
thinking?
gas prices
Got a
won't
gallon
change.
for like 6 cents because they like weren't paying attention, so like everybody got a gallon for like 60 cents a gallon or whatever. But like they messed up. So like there was like for like 3 hours, like hundreds of people went in and got like gas for 60 cents a gallon.
Ouch. I bet that store had to pay.
Yeah.
Crazy. All right.
You want
Yeah,
to know
we're
a
I
funny
was
actually
one
story?
of those people that went in there. I was like, yes.
Now, if you want to know a funny story,
I know it was like the day
We
before
started-
Christmas.
Started up here and ended where on this problem? Started at 576, ended up at 216, right? Is that right? Are those numbers? Which one's
Oh.
the original value in this problem?
5 cents.
If we're decreasing, the higher number would be the original value, wouldn't it? So start high, end low. What's the original value in this?
7, 5, 7, 6.
Yep. If you're decreasing, always start with the highest number as your original. If you're increasing, start with the lowest number, right? Okay? We're decreasing some, so we're starting here, we're going to end down here. Start here, end down here, right? So in a decrease problem, the higher number typically is your original. Would you guys buy that?
Yes.
How am I going to find the percent of change here then, kiddos? What am I going to do? Somebody tell me. What am I going to have to do? Thank you, Mr. Slater. I've got one up front. Thank you. What's the formula, kiddos?
I'm going to guess it's 576
Big number.
minus
Whoop. Okay.
216 divided by 576.
Okay, 576 was the original. That's the reason we're choosing this number for the denominator. Anything else you want to choose to do to those values you've substituted in there?
Times 100.
Okay, so let's find out what our percent of change is here. $576 minus 216 divided, or I'm sorry, what did I forget to do? I forgot to press equals. If you do that, it's going to mess you up. Okay, 576 minus 216, I got to clear the whole thing. 576 minus 216. What do you gotta do right here before you divide?
Equal
Always hit equals. Now we're gonna take that value and divide it by
100
576 times what?
times 100.
Equals 62.5.
So what's the percent of decrease?
62.5.
So if I said something cost $576 and now it's only $216, what was the percent of decrease? How much how much did we put that down as sale? How much did we mark it down? So almost 63%. I'll call this 62.5%. Okay, 62.5%. What do you guys think? Can you handle this so far?
Yes.
Oh, speaking of sales, apparently Apple's gone down by 1.48%.
Really?
Yep.
Good thing I'm an Android guy.
Interesting again.
Still Apple. Don't worry, no bounce back.
Oh my god,
All right.
I saw a commercial for iPhones out. I'm like, I know.
They always bounce back.
1.4% for them is a drop in the bucket. Using a percent of increase, it says a professional baseball team announces that average ticket prices to one of their games will be 8% more than what?
Than last year.
Last year. It says if the average ticket price was $12 last year, how much will it be this year? Okay. We're going to use a percent of increase right here. Okay. I've taught this one way in the past, and I think I'm going to do something differently this year. Okay. I think I'm going to do this differently. All right. Percent of increase, percent of decrease. This is the one where we're trying to find a new price, right? We're not doing big minus small. Don't you already have the percent this time here?
Yeah.
Okay, if you're given a percent, here's what we're going to do. Okay, I'm going to give you some steps for this. The first thing you're going to ask yourself is this. Is this an increase or a decrease? Is this an increase or a decrease, percentage-wise? What are you going to tell me? In this example, is this an increase or a decrease? It's going to be 8% what?
More.
More. Okay. So in this case right here, you've got an increase, don't you? Of 8%. All right, so here's what I'm going to tell you to do. In this case, if it's an increase, I'm going to say add 8% to 100%. Okay, add 8% to 100%.
That's an increase.
Because it's an increase. If it was a decrease, what would you do then? Subtract what? Subtract 8% from 100. Okay? And I think the next example is a decrease potentially, all right? So in this case, we said it's a percentage of increase. So I'm saying, here's my percent of increase, 8%. I'm telling you to add 8% to what? 100%. Okay. Now, what's that make then, percentage-wise?
What?
What's that make here for a percent?
108.
Okay, so to find your new price, right here, my new number is going to equal the following. It's going to equal the original value times our new percent divided by 100. Okay? So the new ticket price right here is going to equal the original ticket price times our new percent. Our new percent being what new percent right here, kiddos? 108%. And then divide that by 100 since it is a percent, right? Okay. So let's find this new ticket price that had an 8% increase to it. Here's how it works. The new price is going to equal, what was the original ticket price, kiddos? $12, right? $12 times, what's my new percent based on the markup? What's the new percent? 10 what? 108. And then you're going to divide this by what value? 100. Okay? So let's check this out. I'm going to take 12 times what first, guys?
108.
Now when I get done with this, my answer is going to be higher than 12 or lower than 12. Why higher? We said the price is going up, right? What do I get when I do that? $12 and 96 cents. Okay? Guys, basically what we're saying is this. I'm going to write this down quickly. Well, 12% was originally the price of a whole ticket to begin with, right? So that was like 100% of the ticket. But we're going to take 100% of the ticket and mark it up what percent? Well, we marked it up 8% more, didn't we? So the 100% represented $12. We're marking it up 8% more. This problem is really saying something that we've already done in the past. Watch what I do here. Do you guys really agree now that we're paying 108% of $12 in this problem right here? You guys agree with that? Because it got marked up how much? We're paying for 108%. Okay? Originally, $12 was the whole ticket, all 100% of it. But now we're going to move that up 8% more. Well, you guys, you remember your proportion on this stuff, don't you? 108% of 12. Isn't this really going to be 108 over 100, percentage-wise? Like this. And guys, the way I wrote this again, we're really saying if this is 108% of 12, where's that 12 going to go right here in this ratio? Top or bottom? Watch what I do here, guys. To solve this, wouldn't you do 12 times 108? 12 times 108? Isn't that this part right here? 12 times 108? Mm-hmm. And then divide by what? 100. Isn't that exactly what this formula is saying in not so many words for our old formula here? 12 times 108. That's this part, the original times the new percent. Divide by what? Isn't this proportion really this formula? Same process, isn't it? This is just a fancier way of writing that proportion over there, isn't it? Okay. So anytime they ask you about, say, hey, I'm going to increase something or decrease something by a percent, the first thing you're going to do is ask yourself if it's what? Increase or a decrease. In this case, it was an increase, so I had to add what? 8%. To what value? 100. And then the formula, your new price, or new whatever, new value, I guess, is equal to the original value times the new percent divided by what? 100. Divided by 100. Okay? All right, let's look at the last page here quickly on our notes. Ooh. This is an interesting one. In 1990, let's not talk about gas anymore. Let's talk about light chunk tuna. All right, maybe if you lived in Seattle, that would be an interesting problem. But we don't live in Seattle.
My family did live in Seattle.
Really?
Yeah, but I was born in 2000, and we had to move here.
Did your family ever go down to the market and people just throw raw fish at them? I always wanted to do that. I always want someone to throw a fish at me and catch it.
Huh? Boston Tea.
Nice. Okay. Says in 1990, the average price per pound of light chunk tuna was $2.11. $2.11 per pound. It says by 2001, the average price per pound had, done what?
Decreased.
Good for customers, bad for business owners. Decreased by 7.1%. What was the average price per pound in 2001? Okay, here's what we need to do. What's the first question I need to ask in this if they give me a percent of increase or a percent of decrease?
Decrease.
It's a decrease. Okay, so we first of all, step one. We know that this is a decrease. Okay? So guys, what are you going to do with that 7.1%? In the last problem, we added 8% to 100. So what do you think we're going to do with the 7.1% this time? We're going to subtract it from 100. So here's what we're going to do. To find our percent, we're going to take 100% minus what, guys? 7.1%, right?
Yes.
Okay. I'll just tell you that that's equal to 92.9%. And it makes sense. We're not paying for the whole thing anymore because it's got to be less than 100% because the price is going what? Down. Basically what this is saying is you're paying for 92.9% of the original. You're paying for 92.9% of the original. So I gave you that formula, the new value. The new value equals your original times the percent that we're working with based on step 1 divided by what? Well, divided by 100. So my new value equals, what was the original cost per pound of light chunk tuna?
That sounds gross.
Ugh.
I like tuna fish. I like tuna steaks actually.
$2.
$2.11, right?
I didn't know that light chunk tuna would
You guys like salmon?
No.
I hate fish.
How many of you guys go to Sakura or the Tokyo place?
Me.
If you ever go, you gotta get the salmon.
No.
Oh.
No, I don't eat fish.
I get teriyaki.
Catch and release for me.
That's some picky eaters in here, Mrs. Miller.
No kidding, wow.
Eat steak.
Times
but
100.
Times what?
100.
What?
Did you just?
92.9.
92.9, that's a percentage we're paying for now.
I think that's a radio station too.
It is.
Okay, 98.5.
Divide by what?
Divided by
I have a question. Had my answer either be more than the original 211 or less than 211?
less.
If you get an answer that's more than $2.11 in this case, because what are we doing to the price? Increasing or decreasing it? You get something that's more than 211, you've done something incorrectly, right?
Yes.
Okay, so $2.11 times what? Divided by 100. Now we're talking about things monetarily. So this would be $1 and how many pennies?
96.
Wouldn't that be $1.96 right there?
Yeah.
Okay, so the cost now is about $1.96 per pound. Okay. Reasonable answer. Why would 196 potentially be our answer here? Well, it was a percent of what? Percent of decrease, meaning that my new price had better be more or less than the original of 211. Are we confirming that here? Okay. How do you guys feel about this? All right, I'm going to try some problems on your own, kiddos. I'll write this down. The answer is $1.96 per pound. Okay, what I'll tell you is this. The on your own's right here. This is like examples 1 and 2 right here. That's the big minus small over the original. And then this one here is like examples 3 and 4. Find your new percent, times by your new percent, divide by 100. So I'd ask you guys to take a minute or two and do those 4 problems on your own. Once you've got that down, get your answers down, check with a neighbor, see if you agree. And if you disagree about anything, talk about why you disagree. Okay? need more time with those four? Anyone? Give you about 30 seconds here or so. Okay, my first one right here says we started with an original value of 25 and went to 31. I gotta find a percent of increase or a percent of decrease. Looks like these are a percent of increase. Original was 25, new was 31. So if I go big minus small, what minus what up top first, guys?
31 minus 25.
31 minus 25 over what?
25.
25. And then times this by what?
100.
What'd you guys get?
24.
24%. How many have 24% there? Okay, 24% increase here. Good. Okay. What'd you guys end up with the next one there? Answer. I'm gonna have 30% for the second one. Mason, tell me what you did.
I took 195 minus 150 divided by 150 times 100.
Okay, and what'd you get there?
30.
Good, 30%. Okay, 30%. Very good. All right. The other ones now. Find my new value. You would have to take the original. What's the original here, guys?
54.
Times, what's the new percent we're going to use in this? It's a 25% increase. 125. So we're increasing by 25%, right? So we're going to take 25 and add or subtract from 100. Add it, right? So times 125 divided by what?
125.
It's a percentage round. Last step, divide by.
100.
Okay. What'd you get there? 67.5?
Yeah.
Okay. Are you guys agreeing with this? Everybody agreeing? Okay. Increasing by 40%. Let's see, that's an increase. So I'm going to add 40 to what value? 100. So I'm going to take 78 times what here?
Times 140.
Yep, 78 times 140. Divide that by. Divide that by 100. Okay. Oh, I don't know if I can do that one in my head. Can I try?
Sure.
7, 8, 15, 6, 31, 2, 109.2?
Yep.
Woohoo!
Good.
This old part still got it. Fine. Totally normal. Guys, what questions have you got? Anybody have questions today? All right, I'm going to stop this here. I'll get you your book page real quickly.